Hello everyone and welcome back to my channel. It has been quite some time that you and I see each other, but I think it's finally worth it. I'm back with Houdini 20.5 and I'm showing you a couple of new features that I really wanted to dive into. One is Copernicus, one is using the slab comps, one is using Solaris and LOPs, instancing, the new MaterialX shaders, Solaris, all of that stuff I'll be showing you today, going again over crystals or minerals. So I hope you will enjoy this tutorial. It will be quite a good walkthrough, but it will show you all the steps that I did, and I think it should be quite easy for you guys to follow. So be sure to subscribe to my channel to keep up to date with new content that I will be creating. And before we dive into it, I want to say a big thank you to everyone supporting me on YouTube and on Patreon and on Discord and on all the social media platforms that I am active on. It's a really big help to me, and I appreciate all the support in the last couple of months, because I have been quite busy on a personal side and also on my work side, so quite occupied there. But I'm finally back into the groove to create some more tutorials. What I will talk about today is Houdini 20.5. It has been released a couple of weeks ago, and I will be talking about creating minerals, creating instancing, using variants. Then we're going into shading using Karma XPU, showing some nice little tricks within the shading networks. And then we will be using the new Copernicus slab comp nodes to have interactive slab comps, so we can actually preview the final result right in the Houdini Vulkan viewer. So pretty epic stuff, lots of fancy words, but I think it will be really worth it. And yeah, I think that's all I had to say. Let's dive into it and check out those new minerals. Also, the scene files are as always available on my Patreon, and you can see the link in the description below. It's always great for you if you check out the source files tier. It really helps me support, and I can create more content for you guys. And I really want to thank all the members that stuck around for this long, and it just keeps helping me going. Thank you so much, everyone. And now let's get going with Houdini 20.5 and Solaris. As you can see, we are back in Houdini. It has been quite some time, not just for you, also for me, but I'm finally in Houdini 20.5 and I am directly in stage, and you can see this is now my scene. I have nothing in the object context, so everything is pretty clean. All I do is I work in LOPs by pressing N. I can jump easily to the LOPs stage, the Solaris view, and this is now my current view. And I have a pretty nice structure. I have everything marked properly where I'm at, and inside each of these little LOP nodes there's more stuff to see. And we are starting at the top to create the material, the base rock shape, then we do prototyping, then we do the instancing, we have a little turntable set up, creating a simple environment light, quick shader, material library, labs, Karma nodes, render ROPs, slab comps using Copernicus, comps, deadline export. And on the left here, you can already see I'm using the new slab comp feature. So everything actually that you see is done right in Houdini. There's no external compositing tools being used. And now running with XPU, you can see now the crystal hopefully coming up. And that is my crystal. And it's a little bit slow because the material I'm using is quite expensive, using transmission and scattering and emission within all of this, so it's quite slow to compute. And for that reason, I do have on the left hand side a quick material that is also new with Houdini 20.5, and you can see how snappy this now is. So if you just want to check out lighting, whatever, I really recommend you this quick surface material. And then it's off my main data stream, but I use that to create lighting, and then in my mainstream, I created these shaders. So that is the basic idea. This is the setup, and I have the references here. And I was told several times these are not crystals, these are actual minerals. And I keep saying crystals because this is just embedded into my brain. So if you feel that it's not appropriate, you just have to live with this, because I will be saying crystals for a long time, I guess. So I think it's now time to start deep diving into all of this. And this is not my first Houdini tutorial, so I will not be covering all the basics. I try to let you know about hotkeys and all of that. Shift R, you kind of can enable and disable the previous render step. So Shift R is back to my Vulkan view, which is also new in 20.5. Yeah, so let's get up to the top here. As I said, I'm not working in object context, but in LOPs you can create object context. So sub create, if you dive in here, this now brings me in a completely normal OBJ context. So you have all your OBJ nodes, and you can see this is now my little setup of this initial kind of rock. It's quite high detailed, and I'll show a little bit how I set all of this up. But this you will get the scene files obviously if you follow me on Patreon. So I will just explain the basics or the important things, and then based off that you will need to figure it out yourself or get my scene files from Patreon. So starting out, we start out with a simple box. Let's just click here to make the view a little bit bigger. Just a box. I'm assigning a couple of breakups. So if you go to the front view, spacebar 1 and 2, you can see it's not a straight box as it was initially. I'm just breaking up the position paths, creating p-scale. This is mainly used for breaking up the bevels, which I actually don't use anymore. So this node can technically be removed. Subdividing it to get it a little bit round, adding a mountain SOP to get some shaping, and then using the beta quad remesh node from 20.5, which just gives nicer edge flow. And then I'm subdividing by a lot to just get more details in here. And this will come in handy later down the line. Adding normals to it so it's all smooth and not jagged. And I kind of like these kind of dents here, so I kept them. These are kind of artifacts from the quad remesher, but I kind of like them for my initial rock or mineral shape. And then you can see here at the bottom, I'm using a Boolean fracture, which has a second input. And the second input is coming in from my basic shape. I'm using that, creating an ISO offset, which essentially creates a point cloud. This is way too dense now, so I can probably just get it lower so it's a lot quicker. And then I'm just scattering points at the moment, 3 points in here. And the reason for why I'm doing this is I want to create these kind of cutting planes. Using the fracture, you can see now that these cutting planes will actually fracture the geo. And in the exploded view, you can now see what they actually do. And I can change my scatter, so I can use a random different seed, and then we get a completely different result. This will obviously be random, so if you have recreate this, you will probably not get exactly the same look. Exploded view. So this is now the first thing, which is quite a nice trick. So on the right hand stream here, you can see I'm using the exploded view. I'm packing it, and then I'm doing the packing, which essentially combines each primitive. You can see now we've got all these 164,000 primitives into a single primitive point. And if I bring up my spreadsheet here, you can see now we just have these 0, 1, 2, 3, 4, 5 points. And then I'm using these, it's kind of like a group, a packed group of these initial primitives. And then I'm using point sheet that should just offset them. You can see if I go crazy, it's just moving them in a random orientation. And then I'm unpacking again. So I just did that to easily just offset them. And now the cool thing is, in the point VOP here, if you see what's happening, it's kind of now blending them back together. And you might be wondering, how is this actually happening? That you kind of have now these cracks. It's actually quite simple. If you're familiar with compositing tools or just in general math nodes, there's something called like a lerp. And a lerp function has input A and B, and then a mix which then blends between two states. So one state being this, and the other state being this. And then inside here, you can see I'm importing the points from the stream B, which is I'm getting just a p-value. So every point position for every point from here. And then I'm mixing this. That's my lerp function. So mix is actually also a lerp. I'm just mixing input A, which is my initial stream, with B. And I'm using a noise, anti-aliased noise, to kind of mix between. So it's based off a noise pattern. So if I go back in here, you can see I have my frequency. So if I change the frequency, you should see the details appearing differently. You can now see it's very high frequency or very low frequency to get more or less the breakup or effects you want to have. So it's pretty handy. Can create really cool effects with that. So let's just leave it at that. So that is the first step. You can see now we went through the fracture and detail step. So now comes the VDB and masking. This VDB from polygons at the moment is probably set a bit too high. So for just the tutorial, I set it on 0.01, which is not that detailed, but you can now already see we're creating this VDB signed distance field. And with that, I can actually create some really cool effects using these volume VOPs here. And this step here is I have to do this beforehand before we go into the volume VOP. But technically what I'm doing, I'm using the convert VDB and I'm converting this SDF to a fog. And I'm just creating 3 instances of that with different name attributes. And the reason I'm doing this is down in shading later, I want to create individual masks of, let me show you the masks actually, like this. So I have these masks which I can apply different shaders or scatter different things on, and this is kind of the idea what's happening up with these steps. So it's essentially 3 placeholders are merged together, and you can see if I hover, I have now these steps, holes, bridges, and density. Density is from the STF, and then these 3 are additional masks that I want to fill in some details, and that all happens within this volume VOB. And a volume VOB is just a node-based network to help me create details technically. Now it seems probably quite daunting with all the wires crossing. Let me see if I can explain this in an easy way. You can kind of see that there's like these 3 different layers here. This is just adding them together. So these 3 layers are creating something, and then they're just being added on top here. If we start with the initial one, let's just actually go back out a little bit so you can see what will be happening. If I just, for now, disconnect this, you can now see this is happening with all of these exposed parameters. So there's always a min and max, and if I change these values based on them, the look drastically changes. And what it's doing, I'm adding a noise pattern, adding or subtracting it to the original surface fields. And this is what's happening here. So I am piping in the position, and I'm creating a simple noise. There's nothing else to it, and noise, and then I'm fitting the noise in a specific 0 to 1 range, or whatever the values are here. This is essentially a noise value that I'm adding on top of the already existing density of the surface distance of the signed distance field. And then I'm repeating this process 3 more times. So you can see add. So if I color these are actually the nodes that are adding the details. And I have switches. You can see these switches up here. These I just did them for me so I can easily enable them or disable a certain mask. You can see now they're enabled or disabled. This one, I think I disconnected the point at some point. Yeah, so here's the point back. We are still back on 0.01. You can see full interiors on. And now based again, if you look at this, you can kind of see the other masks now because they are kind of in here. But you will see if I disable them, they will also be disabled in the output. You can see now it's pretty smooth, and now I can just enable the add nodes again, and that creates the details. It's probably a lot to take in what's happening inside, but once you understand the concept and the layering, I think it's quite straightforward. And then you might be wondering, how do I create these masks? And you can see now each of these 3 layers has this just a bind export node, and I'm targeting specifically a specific name, steps, bridges, and holes. And these are now, these masks that I created are just piped into these volume fields. At the next step, I'm transferring, you can see in my Vex code, I'm doing a volume sample. I'm kind of gathering all the voxels in steps, and then I'm just applying this to a simple float field, transferring them over. So here I'm isolating each field, then transferring them over using the inputs here, 1, 2, 3. And I have my mass transfer, then I have the detail maps here. You can see now how they come through. Steps, that's P, and ridges. So they're all working quite nicely. And then I'm creating also an ambient occlusion mask, which just creates me some details. It's a bit hard to see now, but you can see whatever it's occluded, it gets darker, and within that, I then create scatter points. Right, so we will now work off my cached file because it's way more high-res and way more interesting to look at. You can see it takes a bit of time, but this is now the high-res version, and the same approach. You can see we have all the same. We've got the cut surfaces, and if I go here, we all have the same mask, the bridges, the holes. Kind of everything is still there as we had it before. It's just a more detailed version. You get the detail by cranking or reducing this number here, but don't reduce it too much. Your system will lock up because of memory issues. In here, a little bit of cleanup, attribute deletes. The log primitive naming is just used to create a name that is then visible in stage. So I'm just naming it crystal fluorite. And this is quite important, the rest for shading. is creating a rest attribute, essentially just storing the current P position under a new attribute called rest. So it's a vector. And then the same for the normals. This is needed for when the crystal starts rotating, that the noises within are sticking to the surface. That is the idea here. So that was the first, let's go back all the way, all this detail here. And then in the sub import, one thing that is important is to make sure that your attributes are being imported, import data, and then everything should be as expected. So if I now go into my crystal fluorite selected, you can now see all my primitive ridges, holes, rest, normals, all in here. So now I can use them in LUPs. The render geometry settings is just for subdividing. So I just disabled the dicing quality, so it's not subdividing very much. So it's essentially just keeping it as it is. And then comes the next part, which is the prototypes. And prototypes, what I mean by that is the little fracture crystals that are now scattered all over the place, which gives us this nice, interesting look of the crystal. And I'm using the LOPS instancer node with the name attribute as my prototype index. So this was a little bit gotcha. I first had it to index attribute, but that for some reason always produced some weird outputs. So now I just used the name attribute, and that worked totally fine. Okay, let's talk a little bit how this works. So the instancer, it's just a basic node that expects target points and prototypes. And target points is similar as a copy to points, is on which point you want to create an instance on. And by default, it points to internal sub. There's nothing in it, so it won't do anything. So you have different options here, what you want to do. And in my case, I'm using the internal sub as well, and I'm creating points within here. That's pretty much it. And then your prototype is just where are you gathering the prototypes from. And for me, the prototypes are just this, kind of bunched up things of cubes. Let me show you how I did them. It's actually a fairly simple process, but it's quite fun to do. Based off a single box. Let's just maybe make this smaller. And I'm using a points per volume just to create some points. Then I use a Voronoi fracture on the mounted, so I'm just skewing off the surface a little bit. You can see already we've got these fracture pieces. I can use the exploded view, and then you can see this is now my frac pieces. And then I'm deleting smaller ones. So you can see now if I do the exploded view from here, I'm just deleting small pieces just to get the bigger chunks. Then I'm creating a connectivity attribute, which will allow me to loop over them and also do some specific name sets on them. You can now see I'm using the class attribute based on primitives, and I'm creating this attribute name, which you can find now here in my spreadsheet, P0 to 10. I'm also looping over them, and what this for loop is doing, it's essentially just moving everything into the origin, center of the universe, and then it's just packing them. Regular pack, and then I'm just transferring the attributes name and class onto the points itself, and I'm doing this 11 times, and then that is this. The max variance, I will use that in a different LOP node, but what this is doing, it's actually checking the class attribute. I guess it's here. I'm looking at the class attribute, I'm promoting the attribute to the detail page, and I'm naming it max variance. So it's essentially the promotion method is maximum, so it looks for the biggest number, and then I can use that in my instancing setup in the LOP target points. All right, so now let's go back to one more. That's just a color attribute just to get them blue. And now if I look here, you can now see that everything is instanced. And now let's have a look into the part of the instancer. Let's hide other. So this is my nice random colors. At the top, I'm bringing in my mesh like this, cleaning it up. I'm creating a density attribute, which is based off the ambient occlusion mask, which is essentially means whatever is occluded will get points. Let's see why it's not showing. There you go. So you can see it's a grayscale value. Whatever is occluded will generate points. This is the density attribute. And then on the scatter align, you can now see that I'm using this density attribute here to scatter those points. I'm using random orientations, and then that's pretty much it. and this one is the variant setup, and this is why I was saying I'm picking up the max variance that we created in the previous step, and this way this is fully procedural. If I create more prototypes, this will increment automatically. I'm setting the same thing as I did previously onto the primitives here. So class and piece, they have to match up. That way the instancer knows which name attribute belongs to which prototype, and therefore it can just easily create them. Random p scale, just bigger, smaller chunks. And in here, I'm pulling in my prototypes just for testing. This on the left-hand side. Connect this now here. This is now my testing phase, and I did that to quickly create these points so I have a good idea what is happening. Random p scale, I can change the sizes. I can just have bigger ones or whatever. This is what I did here. And then the output of this, so these points are going all the way up here. And then I'm just filtering by the big ones. I just want the big chunks to get a little bit smaller detailed chunks on top. I'm unpacking them, scattering more points on them. Same thing on what we did on the left-hand side. Testing color is green. And in this case, my testing results looks like this. So this is what I did. And now I can see, okay, I created these smaller little chunks on the bigger ones. And that's pretty much it. And if I now go out, these results are now matching. So the name attribute is working, and I'm now creating the small pieces onto the crystal. Then simple camera creation, look through camera. So we have this, and then we have a turntable setup. And I use a SOP modifier up here because I want to use the object context labs turntable node. And in the SOP node, I'm using small details and mineral as my primitives that I want to control. You can see it's these two. I can hop in here, and then you've got it's actually maybe not a labs node anymore. There it is, labs turntable node. I'm initially just skewing it, so changing the axis, and then the turntable just loops over your frame range. That's pretty much it. That's all I'm doing. 240 frames, so 10 seconds. Then I'm creating a very simple light, just HDRI Haven Snowy Field, HDRI, nothing special to it, a little bit of rotation, and then as I said, I have this new Houdini 20.5 quick surface material assignment. If I now hit Shift R, back to Karma XPU, this is now my Karma setup. I can look into my camera, I can scrub, you can see everything is moving. If I now would want it to change the light, I can just middle click, rotate the light. This is now what it looks like. This is how I did the lighting pretty quick. And then we go into shading. Shading is also fairly simple. It's very similar to Arnold actually using Karma. So if I now Shift R to stop rendering, hop in here. The thing is, which I don't like, once you have a shader assigned, kind of breaks the look in the viewer. The only thing to do it is disabling this, but then if you render again, you don't get the shaders anymore. So it's kind of not ideal. So I'm not sure if there's a better way of doing this. Probably there is, that I just don't know about. Probably use the surface material, but I couldn't get that to work neither. So let's up in here. You can see this is actually old. Get rid of this. Got cube and cubes. Very clever naming here. Cube is actually the rock, and cubes is the little small pieces all over. And yeah, you can see I tried the surface material, but I couldn't get this to work properly. And this is my shading network. I'll again just probably talk over it and show a little bit of gotchas here and there. So if I hit Shift R to get XPU running, it will take always a bit of time because of the larger network here. All right, so initially this is now what it looks like. A cool thing which I learned is you can hit actually X on any node, and this will create this visualize node, which then allows you to quickly see a value similar like you do in Arnold with the isolate selected mode. And also, let me just hide the cubes for the moment. All right, so these are now the masks we created. And I'm just using this as it seems for the moment, just to create the glass and the non-glass surfaces. And let's go all the way here. I created this little subnet, and this is important to get the shader working so it's sticking. So I'm using the MaterialX position shader, and I'm piping that into my fallback for my rest vector. So I'm using this USD prim to read it from the surface, and then I'm just outputting that. And the same thing for the normal. I'm just reading it from my object and then creating this into my subnet. And then based off the subnet, I have my rest and my rest normals that I then can apply to anything that I want. So in this case, triplanar projection. And this node here is just pointing to 3 different textures that I use to project onto the geo. And this is now the triplanar projection onto my geo. And this MaterialX multiply is just a simple math multiply node, but this allows me to increase the frequency. So I'm essentially just multiplying the position pass with some value, and that allows me to play with the repetition, like so. And obviously then we can just easily change the values, go back to what we had before. And then this is just offsetting that. So it's pretty straightforward. And then I'm reusing this rest node several times in my data flow. So let's see what we can. So this is reading in the primrose. I talked about that. And then I have just a couple of simple MaterialX nodes. So essentially a MaterialX node is just clamping values in and out. So if I view from here, then based off this MaterialX range, I'm creating a height to normal. So I'm just using this grayscale value to create a normal map from it. And then based on these input masks where I have glass or like essentially the mineral versus the rock surface, based on that, I'm controlling the bump map height. So also it's all, I think, coming from a lookdev context, pretty straightforward, using lots of multiply nodes to change the frequency of textures or shaders, and then using ranges to control the look. Similar to the roughness, I'm just using the roughness value of a constant for the glass and then a texture to drive the overall surface. This is the base color. So again, using the holes primvar, that is a different mask. Then I'm using the ambient occlusion, and then I'm just multiplying all these things together essentially to create the look that I'm after. And this will just drive the base color for the rock. I have transmission color, which is then driven by the inverted mask, and you can see the transmission color is driven by an upstream node, this one here, which drives also the cubes down below. And transmission, again, is just based off the mask, the inverted black and white mask, and I'm using this to mix in a color for that going into transmission. It's the same shader as the Arnold standard surface shader, so all very straightforward. I'm using the same transmission color to just pipe in a little bit of emission into the crystals. It just helps to give some kind of volume to it. And then obviously the bump map, which I created up here, goes in there. I have a displacement map, which just adds fine detail. So the displacement is just using the same rest network. A fractal noise, MaterialX fractal, adding some octaves to get high frequency detail, passing in a position pass. Then we go into displacement, a displacement height, and that goes into my subnet or material outputs. So actually very straightforward shading. And then cubes is even simpler. It's just a very simple material. I could probably spend more time in this, but I'm just using transmission and emission, and then higher index of refraction to get some nice glossy pinks off it. So if I now go back into, let's see, actually, I think I still have that X thing enabled. I think we can just X this again. So this is not disconnected. And if we go all the way back now, this is the shading network. Yeah, as I said, pretty straightforward. And the next step is then, how do we actually get this to render? And we are now at the render settings step. So I'm creating this labs Karma node. Let's go back to the camera. Within here, so this is just, if you go labs Karma, this is this node. And this node allows me to quite easily do render settings and outputs. It has also versions, so I'm providing it a base name. You can create the output version. The frame range, you can render to disk, to mplay. You can use the top networks to create it in the background. Pretty nice stuff. Render settings, I don't know, pretty low pixel samples because I'm using denoiser. I'm using the Intel Odin denoiser here. My renders resolution set, AUVs for comp, all of these. So I have indirect direct diffuse and reflections. I've got emission, and I've got depth, which is important for depth of field. That's pretty much it. They pipe into a UST render up that then I am in turn using to submit this to deadline. I have a little, like, two machines to help me rendering. So these two go into my fetch robs, comp rob fetches, and then submitting them to deadline in a dependency setup. So that is why that is for. I have slab comp and comp. So the comp one is actually reading the file from disk. You can see this is now reading a file. Let's actually go to a file that exists, which would be, I guess, 11. Yeah, I think that exists. And then I will walk you through the actual comp steps. And I'm using the Sapphire tools as well. So in case you're wondering, there might be different Copernicus nodes that you don't have. It's just because I installed the OFX Sapphire tool sets. So this is now reading the file from disk, and the slab comp is exactly the same thing. It's just, it has this slab comp import node and the block ends, and everything is in essentially in a compile block. But the comp version is, as I said, it's the same thing. It just has this comp out ROP that I'm using for the deadline render. So I'm writing that to a different disk comp file. And to create that slab comp thing, all you gotta do is type slab comp, and it will create you everything for you. You can see it, all of that stuff creates it for you. But now that we are working with the slab comp, so the file from disk, let me just walk you through the steps here. Let's just zoom in here. I'm not sure why this is so blurry. Okay, so the first thing is grabbing the HDRI, and the HDRI is being grabbed from the light. So if I see this is my HDRI, like this. I blurred it a little bit already, and then I'm just using the blend over mode to put the crystal over the background. And then I'm using already the first AUV, I think the emission one is this. I'm using a channel split to just get the alpha, and then I just kind of join them again, so it's just kind of extracted from the background like that. And I'm using the first Sapphire Ultra Glow 2 node, and this gives me a subtle little glow effect. You can see if you go from the previous one, the internals just start glowing, and if I play with the brightness, you can see this is now done in Copernicus compositing within Houdini with these additional node add-ons. And then I'm doing another glow on the specular, combined specular passes, doing the same thing, isolating it from the background, and then doing this on top. And you can see if I play with the brightness, this is kind of what it's doing. Pretty straightforward, just to create a little bit more interest and glows. The next step already is the lens. Sorry, first did I sharpen. Maybe it just adds a little bit more crispiness to the render. And then I'm using depth of field here. You can now see this is a little bit out of whack because I have to adjust it per kind of crystal. I rendered a couple of crystals, so this doesn't work for this specific one. But I'll show you how to do it. So first I'm using this equalize normalize node, which allows me to clamp or to normalize the min and max values of the depth pass. Because the Sapphire tool, it's called a ZD focus as well, works from 0 to 1 range. At least in my test it did, so it was a little bit tricky to get right. And then it's just about balancing the remap here. You can see now this is kind of the depth, and you just want the front to be a little bit dark like this, for instance. And then you can go back to the blur node, and you can change the mode to focus zone, and you can now then play with this, which is essentially the focal point, play with the fall off, very similar to other compositing tools do, and then you can again show the result, and then this is your depth of field look for this. On top of that, I'm applying chromatic aberration. You can see now this just gives us this little bit of color fringing on the sides of the lens. Then I'm doing a vignette. I like my vignettes, so it's just shadowing the outsides a little bit. And then a grain, a film grain, which adds also another little touch of realism to the lens. And I have a seed value on that. And all of that, pretty straightforward, goes into the block end. And then, as I said, the output of this goes into my ROP image output node, and this is just running it to disk with my color space set to output sRGB and then as a JPEG. This is the result. So I hope you enjoyed this series. This is essentially the end of everything. So this is now how you use the Copernicus nodes, the new 20.5 general nodes in Houdini. And yeah, this is the result of my crystals. I hope you enjoyed a look. And as I said, all the scene files will be available on my Patreon for you to dissect, look into, and just support me creating more tutorials. So I hope you enjoyed this new Houdini tutorial. There will be more coming. And yeah, thanks for watching, and I see you in the next video.